All right. Thank you for coming here tonight. Since the YouTube doesn't work out to share the PowerPoint, so I just use the Google Meeting. Just need to be creative. Use the Google Meeting to record it, and then afterward, I will upload this video to YouTube so that you can still have the full experience of Love Makes AI Simply Fun. All right. Hello, everybody. Paul Wu here. I'm a principal data scientist working for a biotech company in the Bay Area. A little bit about myself. I have about 12 years experience in data science, machine learning, and AI. 6 years in academic research setting, another 6 years in industrial, from startup to big enterprise. Since I was at school, mathematics, algorithm, abstract concept, that kind of technical things is kind of a norm, right? For a graduate student, a researcher, even data scientist, machine learning engineer, right? It is the peanut and butter, basically, follow you all your life. So unfortunately, that kind of thing is not necessarily fun, not necessarily the fun thing of the data science, machine learning, AI work. And because basically you don't speak the language of machine learning, you don't speak the language of algorithm, you don't speak the language of mathematics on a daily life. So it is kind of a special expression, for those weird people, for those nerds, and they only a very small percentage of their life they use that kind of language. So it make it not sure, right? And you probably that's the less enjoyable part of being a data science or machine learning engineer. But guess what? Huge amount of wisdom, huge amount of good thinking have been putting into these tough technicals. Because of the language, the format, this thing present themselves, very, very few people appreciate what is inside. Let me give you one example, which is a joke. Years ago, when I was defending my PhD thesis at Georgia Tech, my in-law was invited, right, to attend. And at the end of my talk, it's a 2-hour defense talk. It was very intense. My in-law told me, everything I know that you say is English. On the word level, I understand what that is. But when you speak a whole sentence, I started to thinking you are speaking another language other than English. And at the end of the 2 hours, they are totally lost. They are thinking about, I'm speaking a totally different language. I just happen to use the English word, putting here and there and to make up my thesis. So that's how brutal it is. For ordinary people don't have this kind of mathematics or computational training. This is like a book written from some alien from another planet, right? So guess what? Today we are going to make all these things different. And by the end of it, you will be looking like this. Every concept in AI, machine learning, data science, it's like you are gauging on Van Gogh's painting, like this one. The starting light, amazing, right? You will, I don't know about you, I get lost when I first look at that picture. So much compassion, so much love, so much, I would say, my heart was warm up when I look at that picture. Could it be possible when you look at the concept in AI, machine learning, data science, your heart can be warm up, your imagination can fly. Is that possible? We will see. All right. Another challenging thing in the technical world is algorithm, right? Is that possible if you look at graph ML, graph machine learning, the one of the hottest field in AI, in machine learning at this moment? If you look at the algorithm there, would it be as fun as a 7-year-old enjoy his puzzle? Look like this. Ooh, that's fascinating, right? You don't need to push me. I'm attracted to that kind of fun thing. How about mathematics? When you look at this word, right? Quantum generative machine learning. My goodness, the mathematics in it is like, and I don't want to give you a formula here. Probably if I lay out a formula, how the mathematics look like, all of you will be gone. You're not going to stay in this presentation at all. So, but what if the mathematics in quantum generative machine learning, the most advanced, the most challenging machine learning field at this time, could be look like a bedtime story? Who doesn't want bedtime story? My 3-year-old like it. More than liking it, he love it. He can't fall asleep without a bedtime story. How about that? When you look at the mathematics in this advanced quantum computing field, it's like you can carry that imagination, you can carry that excitement into your dream without having a nightmare, but a heavenly dream. How about that? So let's see whether we can make this magic happen. What about this X prize problem? Do you know that there's an X prize problem? People are giving out like $100 million for it. Sure, it is a very challenging technical problem, right? Otherwise, it would not worth that much. What about solving that problem would be like eating M&M. Ooh, sweet and sweet. I don't know how to describe it, just sweet, right? So sweet and so much fun. Okay, though. But the reality is not as we imagined a moment ago. So the technical thing to most people, probably just me, right? You guys are extremely smart, probably just me. Okay, a lot of time would be like abstracts. What do you mean abstract? When you look at a paper, say I just pour it out, right? If you look at a paper and the things show up in front of you, basically you read the abstract first, right? Say this one. I just randomly draw a paper, which is the kind of seminal paper about the graph-based machine learning, okay? Oh, look at this. How about that? Can you read this? This is the abstract, right? The abstract by itself is very abstract. I don't want to get into it. So it's not easy to, the first paragraph you read probably make your head just spinning. So how about the mathematics? The mathematics to a lot of people is like dead cold. It's like a dead body laying on the coffin. Dead cold mathematics, not fun. What about the algorithm? Algorithm is written for alien, not for a human being, right? It is people from another planet can appreciate that, but probably not me, right? You are probably from the other planet. You can do it, but not me. Okay, how about this? How about the reasoning? Because of this A, then we do B. Because of B, we can do C. Because of C, we can do D. A chain of reasoning throughout our academic paper or a difficult subject like graph ML, right? What do you think? Do you think that it is something you would enjoy doing? Probably not many people, right? So how about the task? These technical people you are trying to solve, or the technical people trying to solve? Usually it's tough task. I basically copy and paste a picture from the internet here. In this is something close to what we think, right? Abstract, that code, eccentric, puzzling, tough. Ooh, look at this. Probably except this lovely, lovely diagram. The rest of it is pretty abstract, pretty much as what I mentioned here. If today I present mathematics, present algorithm, present the concept to you as a PhD, probably you can call my PhD is permanent head damage. So how brutal it is, right? Give me some example, right? This is the first concept in Graph ML. By the way, Graph ML, again, is one of the hottest field right now. It has a lot of promise to change the world, how we understand the world work. And one example, like the AlphaFold, the DeepMind company solved the protein folding problem. Large part of it is the Graph ML, using the Graph ML technique or the Graph ML mentality, the technology from that field, right? So it's very important. It creates a lot of wonder, a lot of wow in this hour, Graph ML. But guess what? The first couple concepts from Graph ML probably will blow you out of the water. Look at the first one. It's called a message function. Okay, message function, right? So look at the construction of this function. Whoa, it's just some mathematical formula seems to be. And M probably represent the message function here on the right-hand side, right? There's a HI here, XJ here, and EIJ. If you read the notation, HI, it means that it is the hidden vector representation of the receiver. Say, think about I as just I, right? I receive something. So this vector represents me. XJ is the message sender from the other party, right? The other person send you something. So this is the hidden vector representation of that person sending you the message. EIJ is it's just like some expression, some vector represent why the interaction between the message sender and the message receiver, right? Why people use the hidden vector here, right? That's kind of confusing. I don't know about you. I don't understand. Why is that, right? So after you combine why these three things need to be in this function, no explanation, right? Why I there, HI there, XJ there, why EIJ there? Then it creates some kind of using this abstract message function, you get some message. Oh my goodness, another vector. How does this vector on the left-hand side related to the vector on the right-hand side? There's no much explanation. Okay, first concept. All right. Let's move on. First concept is already kind of hard to swallow, right? The second concept, oh my goodness, it's called the aggregation function. Aggregation, hey, look at the right-hand side. It's kind of familiar, right? MIJ, that's what we just constructed through this confusing mathematics, right? And also then it has some more complication coming in, which is something like a plus thing, a very sophisticated operator, right? It seems something adding up together, and if you read the notation, what IJ mean, it is the so-called all the labelhood about J, about I, right? I is me or you, right? The receiver. So J is obviously the labelhood, all the labelhood of you, and it is kind of like aggregated together to produce something about the message. Why is that? Right. The second concept is building on the first concept, and it creates even more complication. What about this? The third concept, oh wow, is building on the second concept. Look at the right-hand side, right? MJ has head on it. So this is kind of what the heck is going on, right? And it has the XI and on the right hand side and the XI on the left hand side. It seems that there's some upgrade things going on, like for this hidden vector representation of the message receiver. Oh my goodness! Through this very, very strange function, they don't even use English. They use click, right, to represent this function. It's called update function. Oh my goodness! I don't know, right? I think I should go to the bathroom, and when I'm sitting on the bathroom, I will dump all this thing out. I don't know about you. Like, who will remember this? Like, who will carry this to your bed and have a good dream, right? Probably, if I don't have a nightmare, I will be very thankful, right? After thinking about all these mathematics. So this is the hard reality we are facing, day in and day out. Unfortunately, part of the life of a data scientist, machine learning engineer, and if you are an AI scientist, congratulations, that's everyday bread and butter, right? You have to, whether you like it or not, you have to swallow it. Oh my goodness. What can we do? Okay, come back to our first slide. Love make AI simply fun, making all sense of tough technical as your recreation. Whoa, that's a great promise, but it seems we cannot make it here on the earth. Since something like some years later, when heaven come to the earth, that could be a reality, right? But not right now. You may say, okay, whatever PhD or grand PhD you have, it doesn't happen that way. Probably that's what you are thinking. Oh, just only me. That's what I'm thinking. But love make all things simply fun. That's so attractive. Love just automatically, by definition, right? Love just expel all the fear, expel all the worry. And love is like you expose yourself under the sun and all your body warm up and all your heart warm up. Your heart is filled with joy, filled with hope, and filled with confidence. Probably, can we really ask love for help? Love make AI simply fun. Let's try it today. Hey, guess what? Right now, I'm no longer a PhD. Paul is basically praying and praying, hopping and hoping, doodling and dancing with love as a street kid. Guess what happened? I have 2 PhD right now, praying, hopping, doodling, praying, hoping, and dancing. Ooh, all of a sudden, those permanent head damage is completely healed. I'm no longer that kind of PhD, but this kind of PhD. Let's see whether we can make something different. Okay, let's go. All right. Just a few weeks ago, I have my birthday. My birthday. What a happy day, right? I celebrate. The best part of birthday is you have your good friends coming together to celebrate this very special day. I do. I have Alex, this guy coming. I have Bobby and I have Cassie. They are living just couple block away, couple houses away from my neighborhood. I remember just a couple years ago, just assume that I was still living in that neighborhood. That neighborhood is, unfortunately, is pretty much very unique, I would say. Many people, they live under the poverty line. Many of them, including those kids, Alex, Bobby, Kathy, they don't have a father living with them in the same house. One of my friends in real life, because of the, I don't want to tell their real name, so I just generate these pictures using AI. But the story I'm going to tell you are real. Most of the kids I was associated with doesn't have their father leaving the house. And they live with their single mom, basically. About 10 of them. 9 are African American, 1 is Hispanic. So where are their father? One of the kids' father, unfortunately, when he was 5, he lost him through a shot, through a bullet. He lost his father forever. For the rest of the kids, their father, some of them, 4 or 5 of them, were in prison. And the rest of them, their father were living with another lady somewhere. So that was the neighborhood I was living. But it doesn't mean that those kids doesn't have a future, doesn't have a hope. I do think that they have a hope. I do think that they have a future. That's how love turn the turmoil, turn the whatever past all around. Guess what? The same thing for you. You are probably right now, you are facing layoff just in the high tech. You are probably part of the layoff group from Twitter, from Facebook, from those big tech companies. You were probably thinking about, oh, so much stress, right? So much uncertainty. How can I take care of my family? How can I feed my kids? How can I feed my spouse? How can I pay for the rent? How can I do this, do that? A lot of uncertainty are happening. And that was the same thing a couple years ago when I leave academy. I finished my postdoc training from Yale and joined that the nonprofit organization. And just 300 feet away behind that nonprofit, there's a community living in poverty. The community was infested by crime. But it is not the end of the story. Love was there. Love was there. Love draw those people out of the tyranny of their past. Love actually draw them forward. That's what I experienced. So it was my birthday. Let me come back to this story. Alex come to me with his jar of coins, jar of penny he has saved for about a year. There were 1,000 of them. So he gave me $1,000. I'm not exaggerating, 1,000 cents. That's about $10. So he gave a big jar of cents, a big jar of coin as my birthday gift. Guess what? For people like Alex, at that time, he need to work probably an hour and a half to make about $10. So that's a very precious gift to me. The same thing for Bobby. And he doesn't have the dad to teach him to draw this picture. He doesn't have amazing, a tech skill as a lot of prestigious people, but he gave me a hug. That is the most precious gift I can receive from a little guy like him. How about Cassie? Cassie is an extremely optimistic little girl. So actually, she brings me so much joy by praising me, by helping her with her homework, by helping her with a lot of fun and silly things in her life. So my good friend, Alex, gave me not necessarily gift card, a jar of coins, right? A jar of 1,000 pieces of cents, which is about $10. And Bobby gave me a hug, and Kathy gave me praise. Hey, those are very important message I received that day. So when you think about it, if you want to just put it into computer, right? This story, put it into computer. What the message is affected by, like what kind of factor could be some of the determinant for this message? It depends on who gave you this message, who you are at that point, right? And also what are the message he or she give you, right? The interaction between your friend and you. So at least three factors should be there, right? When you construct, when you want to use, when you want to remember, okay, what this message is, at least three factors. Who is the receiver? Who is the gift giver? And what is the interaction between the receiver and the giver, right? That's exactly why this function, the message function, has three parts. So guess what? How do you represent me? How do I represent Alex? Right? Say you say about me, it could be like the weight and the height and the age, or the title of me. Right? By then I was a data scientist, so my title could be data scientist. My weight could be like 140 pounds, and my height could be like 5.6, right? And my my age could be 40, right? So just for the sake of discussion, right? My title could be data scientist. And Alex also has his characteristic like that, right? His age probably is like just 18, and his weight is that, his weight is that, his title is that, right? Say a gas station attendant. So it could be like that. And how about gift card? Oh, gift card is a message. That's the channel, the interaction between Alex and me, right? So the gift card could be, okay, it has this kind of a beautiful picture on it. It has the face value is 1,000 cents, right? And so on and so forth. You can list probably 10, 20 characteristic about that particular gift card. Okay, that sounds good to me, right? So you use some kind of because when I receive this gift from Alex, it's no longer just 1,000 cents. It's no longer just a gift card. It is a love message. A love message. Alex worked an hour or two. Over the year, he saved that penny. He gave it to me. That means tremendously to me. It means a lot to me. So the message he gave me is totally a love message, right? So you can represent that love message. Here, I just use M1 to represent it, right? So how do you represent it? Is there some component of this love message? Say, this love message basically give me such an impact on my body, on my mind, on my spirit, right? Say my body is, say, 3-dimensional, my mind is 4-dimensional, my spirit is 7-dimensional. So should it be just like a 3-dimensional plus 4-dimensional plus 7-dimensional thing together? Could be, right? Who knows? So we don't worry about that. Okay, the same thing happened when me receive a message from Bobby through a hug. Using this message function, all of a sudden, my body and my mind and my spirit get an impact. I get another love message. The same thing for Cassie. When I receive a praise from Cassie, I actually receive a third love message. My body, my mind, and my spirit is impacted by it, right? So through this story, you can see that the construction of message function actually has a lot of fun in it, right? It is not that cold. It is a story. It is a love story. That's the most important thing you probably can get today. It is a love story. It is a vivid story. It can touch your heart, touch your body, touch your mind at the same time, right? So let's talk about a little bit technical here. Why people use hidden factor? Think about this, right? To describe a human being, you probably can easily find out 10 characteristics about that human, or 100 characteristics about that human, right? It could be his weight, his age, his title, his education, so on and so forth, and the color of his eyes, right? How wide, how long is his arm extension? You can go and on and on and on and on and on, right? Could be a thousand characteristics there. But guess what? Because here we are aiming to describe the message I received from Alex through this gift card. Many of those characteristics is irrelevant, right? The relevant thing could be easily, like say, just for the sake of discussion, is 50-dimensional. Oh, that's too much, right? That's too much. Can we squeeze it into, say, 7-dimensional? For those people, for those friends who are familiar with deep learning, you say that definitely we can. We can basically say we do a PCA, right? We can squeeze that high-dimensional vector into 7-dimensional. We can do that. Or we can using even some more fancy technique, like instead of linear combination of those original features, we create the PC. We can use, say, encoder, decoder, that kind of technology. It is basically a nonlinear combination of the original high-dimensional space or many features, say 100 features, right? Through this nonlinear interaction of those features, we just squeeze all these 100-dimensional into, say, 7-dimensional. Can you do that? Yes, you can do that, right? You have a lot of freedom. You can choose whatever way that can reduce the dimensionality from, say, 100 to 7. So that's why this vector is called a hidden vector. So you may have a question, right? Okay, I can accept that. You squeeze the 100-dimensional law feature into 7-dimension. What does the first dimensional mean? What's the second dimensional mean? What's the third dimensional mean? What's the fourth dimensional mean? You can ask this question, right? Fair. But guess what? Because after this meshing up all these 100 factors, even through technique like PCA, linear combination of it, the meaning become very, very fuzzy. So the element in each element, the first dimensional, second dimensional, third dimensional, to the 7-dimensional element on the hidden vector doesn't necessarily have a meaning by itself. This is the message. But the whole vector, the whole hidden vector, contains the most important characteristic about a human being. Say, a human, me, have 100-dimensional, but the 7-dimensional is far enough to capture the most important thing about me, right? So this is the magic for hidden vector. This is the advantage, right? So you don't need to have 100-dimensional there, just 7-dimensional, even 3-dimensional probably is good enough. Okay, so the same thing, we will have the hidden vector to represent here, in this case, Alex, right? And also we can use a vector to represent the interaction between Alex and me, which is a gift card or a jar of coin, right? A jar of cents in this case. So when you have this kind of message function, you produce, right? A message function have impact on your body and mind and spirit. That's on the right-hand side. On the left-hand side, this M1 doesn't necessarily have the same dimensionality as all these vectors from the left-hand side. It could be, but it doesn't necessarily have the same dimensionality. Simply, it gives you more freedom to create, to design. This is mathematics. Probably not many people see that mathematics actually is the designer's work. It's the designer's masterpiece. It is designed this way for a particular purpose, to achieve a particular goal. So that's what you need to remember today. Any kind of mathematical formula, it is a designer's masterpiece. It designed that way to achieve certain purpose. So that's the fun thing you can find out. Okay, that's message function. How about let's look at some example. Okay, let's look at 3 examples. Say, I can design the message function just taking the representation of Alex, or the representation of Bobby, or the representation of Cassie, right? Just use the hidden vector representation about Alex, Bobby, or Cassie. We can take it as simple as that, right? This is one design, right? Very simple, just the neighborhood coffee, right? Another design is you think about, say I receive 1,000 cents from Alex, right? Say he give me the cents one after another. I have 1,000 pieces. He counted, right? One after another. Although each cent is the same, just 1 penny, right? But there are 1,000 of them. So how do you deal with that, right? So you probably need some kind of normalization. Each cent probably just wants 1 over 1,000, right? So they add it up. So the because Alex give me so many things, and then each of the piece may not worth that much, but altogether it represents the whole heart of Alex. So you need some kind of normalization factor there. So if you don't understand this, just don't worry, right? I'm just using this story as an analogy to explain the purpose behind. So when you see this formula, you can safely say that, okay, that's another designer's shot. That's his design, or that's her design to achieve certain purpose. The same thing, right? Look at the third example. We can just make it more fancy, right? It is something we put special attention between here. I put special attention between Alex and me. I design a so-called attention function and multiply it by Alex expression, right? Alex hidden vector representation about him. So I create a message from Alex to me. If my attention to Alex is big, then there is a big message from Alex, right? If my attention to Alex is small, so I receive a small message from Alex. You see that? It depends on how you design this attention function. And in the machine learning realm, usually this attention function can be learned. Either way, right? It can be designed or it can be learned. I have a family message coming in, so let me just delay talking to my family. Let me finish recording it. All right. So you already have this message function. Guess what? And you aggregate them. You put it all together. So this plus sign actually is just a special symbol saying that, okay, we just like I have a container, right? Put all this message together and add them up. Basically, that's it, right? So I aggregated Alex love message, Cassie's, Bobby's love message, and Cassie's love message, and I have a total love message altogether, right? Is that fun? Like aggregation function, just as simple as that. So let's look at some example. You can do the sum, right? You can do the average. You can do the max of the three, right? So all this either sum or average or max, it doesn't matter which message come first, which message come later. So this is the characteristic of aggregation, right? The order doesn't matter, but the totality matter. So that's it, very simple. All right, the third picture I would like to show you is originally, right? When I live in this poverty-stricken community and crime-stricken community, my heart was that cold. That was the original state. That was me, right? But after I received a total love message, guess what? I get an upgrade. I get an update. So my heart become red hot because of the total love message. So you can design some function. Again, it is designer's fun. It designer's play. You can design it. It is related to who I was, and it is related to this function, right? This update is related to who I was and what I received, and boom, I get become red hot, right? So this is the fun thing about the third function. Isn't that easy? I think it's pretty easy, right? So look at some example, right? And you can do the so-called projection of the total love message into some basically it's a linear combination, right? You can make it even more fancy if you look at the second example, right? You can think about, okay, that's taking care of the original state, who I was, and also think about some kind of linear combination of the message I received and plus some bias, right? And this so-called W self, W label, and B basically is some parameter you can learn from the data, right? As simple as that. So of course you have more freedom than just doing a so-called linear combination, right? You can concatenate the hidden state of me, right? My hidden state, HI, is the representation of me. And the message, the total love message I received from Alex, Bobby, and Cassie. And I concatenate it and basically just put it side by side, right? And then, boom, have some kind of linear combination of this. And the omega here basically is just like an activation function to squeeze it a little bit, right? If the number is too big, I squeeze it, say, between 0 and 1, for instance, right? That's the so-called activation function. Nothing more than complicated to that. Okay, so the update function, you can have many choice. You can have according to the purpose you want to achieve. You have the freedom to design it. Okay, the last thing, right? People say, oh, you haven't explained one more thing. Say on the update function, on the right-hand side, there's a K there. And on the left-hand side, there's K plus 1. What the heck are those K and K plus 1? Actually, it's very simple. Let me tell you what. Imagine a situation. I receive those lovely love message from Alex, Bobby, and Kathy, not just on my birthday. I receive it day after day, every day, say for a whole year. Guess what? My body, my spirit state is coming from that cold to be a little bit warmer the next day. And I receive one more gift, one more set of gift from this friend. And then it goes on and on and on and on. Not just one day, but day after day, day after day, right? So the K lead to K plus 1 is a very simple idea. Basically, you just loop through the message function, aggregation function, and upgrade round after round, loop after loop, right? That's it. So your situation, my situation, is from the earthly, gloomy, hard, cold state, little by little, become warmer and warmer, hotter and hotter. I'm descending into heaven, right? So this is basically what is the K lead to the K plus 1 mean. It means that today my situation is depend on what I was yesterday, and tomorrow my situation is depending the upgrade of my state is coming from my state of today. So that's it. Very simple, right? So right now you can see that technical become like this: analogies, diagrams, examples, plain story, and techie abstraction and generalization. You see that through the so-called ADEPT, ADEPT, technical can become fully alive, become like a story, become like a picture, become like a dynamic. So as long as you are circling by love, you are praying as a street kid together with love, you don't take yourself that serious, right? You don't take yourself that serious. You have fun. Then technical could be as simple and as fun as what we just went through. Is that true? You tell me, right? Is that possible? The concept in AI, ML, DS become Van Gogh's painting? Is that possible? You can look at the algorithm. It's like you enjoy a puzzle that can be enjoyed by a 7-year-old. Is that possible? The mathematics in quantum physics, in quantum computation, can be like a bedtime story. Can you solve X price by eating M and M and M? Oh, MMM here, actually, to me, is MMA, fighting, marathon, running, and mountaineer. They are not necessarily, they're simple, right? But they are fun. They're really fun. So that is today's, basically, we have a kind of candy. The main course is coming up. This is how I make, tough technical, really simply fun. And today we just started. Congratulations. And okay, let me tell you a little bit background about myself and why this idea come to this point. Well, since July this year, I started to write quite a few blog on LinkedIn, something like "Seer, passing technical with 95% confidence." Ooh, that's very attractive, right? I wish I can do that. And in boredom or in crisis, what if you can hear the voice of the 10x future you? Wow. Hear the voice from the future you? Song Hae Lee. That's amazing, right? That's amazing. I would like to know more about that. Check out my LinkedIn article. And more recently, I started a YouTube channel called the Love 12X Future. And I talk about how to defeat year-long depression by days. I did it, and you can too. Sea of Love, simple and easy action, enable you to love tough people and work. Who are the toughest people? Probably just you, right? Not your colleague, but just you. Okay, making all sense of AI with love, and that's the series we are focused. We are going to continue the fun in the coming days. Specifically, I will focus on graph ML and transformer technology because those are the most profound and most impactful AI technology in this day. What about next year, 2023? Okay, we will do really some really challenging and fun thing. Use quantum generative computing as one example, and machine learning system design as another example. And guess what? Also this, Love 12x Future You. Think about this. What if right now, today on, you start to talk and walk with the 12x future you? Say the future you 12 years later. The wisdom he has is available to you today. The loving kindness, the character he developed, the perseverance, the peace he developed or she developed is available to you. The 12x future you started to become available. He is here or she is here, right, to talk to you, to inspire you, to enable you to make daily change. What do you think? Do you think that your future is just nothing but a dream? I don't think so. Your future can be a dream made true today on. So that's what we are going to do in the coming years. So just keep in touch. Last, all this, like we talk about love. What does love do? Love basically is connect you with your neighbors, connect you with the tough technical things you are doing. So how does love do the connection? Love, basically, you are paying attention to somebody or something with the only attitude of love. With the attitude of love, with the motivation of love. That's how you connect you and your neighbors. Something like your spouse or your boss or the very tough person in your team, right? If you hold the only attitude of love, if you have the only motivation, I want to love this person, I want to, including yourself, right? What if you can connect with your future with love? What if you can look at your past without a critical spirit, but love? Do you think that you can build a much better relationship with yourself, with your future self, with your past self, with your neighbor, with your spouse, with your coworker? I think so, right? And when you have the attitude of love, then you started to communicate. You started to talk about the things which was not possible before. You started to understand one another. You started to appreciate. You started to be much thanksgiving. You started to encourage yourself. You started to encourage the other person. You started to think that, oh, the technical paper I'm reading is so beautiful. Your heart doesn't have that kind of resistance anymore to dumb it out. You want to grab them in, right? That is how love do to you. So it is then collaboration. Collaboration and co-creation become a natural following step. When you connect with one another with love, you pay love attention to one another. When you communicate with the language of love, respect, honor, thanksgiving, praise, right? Then you started to collaborate. You started to co-create a whole new world. Isn't it true? Right? Let's do it. Let's do it together. So it's no longer me, but we. All together, we can love. Talk and walk with love. Love will tell us our future. The future belongs to us. Not a single person, but all of us who join this movement. Let love tell X your future. Let love tell X my future. Let love tell X our future together. Keep in touch. And this website, is still in construction, and so it may become available just in a few days. Keep tuned. Love you. See you next time. Bye-bye.